Okay. All right. So, what this is, we've been talking about the similarity triangles. And what you already know about similar triangles is that if you do have similar triangles, the corresponding angles are congruent. So, here's two triangles. Here's an angle here, which I'll just label A. And then here's an angle here that has the exact same markings. And I'm going to call this guy D. All right, so these two angles correspond because they're in the same exact positions in those two triangles. Here's angle up here. I'm going to call him angle B. He has a double arc. And over here, I'm going to call him angle E. And he has a double arc. So you know these two correspond and are congruent. And then finally, this guy down here, I'm going to put him 3 arcs. We're going to call him F. And then over here, I'll do the 3 arcs and call him F. All right, so in similar triangles, what we know up to here is that if you do have similar triangles, the corresponding angles are congruent. Angle B is the same as angle E. So if I told you angle E was 30 degrees, you could tell me that angle B was also 30 degrees. Okay. I'll just put that in there. There we go. 30 degrees. And I'll do a little arrow right there. All right. Anyway, so also what we know about similar triangles is that their corresponding sides are actually proportional. What that means is they have the exact same fraction. So if I tell you that the length of AB is 2 and the length of AD is 4, and the length of down here, this guy, I 1 because he looks smaller than the other one, and this guy right here to be 2, you can see that this triangle over here, the smaller one, is half the size of this bigger one because I multiplied 1 times 2 to get to the corresponding side DF. I multiplied 2 times 2 to get 4, which is the corresponding side DE to AB. So if I set up a fraction, it would be AB to the corresponding side, DE, is equal to AB is 2, DE is 4, reduce that fraction, and we get 1/2. And no matter which two corresponding sides I grab, all three will be 1/2. This will be 1/2, and that leaves me with this side that I don't have a number for, and this side right here, if I had a number for it, I could tell you it would end up reducing to be 1/2. So like if I put I'll put 3 right here. And 3 times 2 is 6. That'll give me this one. So that's scale factor, and that was a lesson a couple lessons ago. Scale factor is finding how much larger or smaller the two triangles are from each other. And to find an actual scale factor, all you do is make sure that you put the image that is what we call the image. That's the one after any type of dilation may have happened to it, you put that one on top. So here I'm saying AB is the image before any type of dilation happened. I'm saying that AB is 2, where its corresponding side is 4. So I'm saying this guy is a pre-image. He's larger, so this was a reduction. Okay, we're not specifically talking about dilations here, but I just want you to know what scale factor is. How much larger or smaller. All right, now this particular lesson here, one more thing before I get into this particular lesson is after you realize you have similar figures, because all the sides are proportional and all the angles are corresponding, you would write a similarity statement. So I would say triangle ABC. I would name the first triangle. And based on the name of the first triangle, I'll put this little symbol here. It's called a tilde, and it means similar triangles. And then I would name the second triangle. You have to name the second triangle specifically based on the name of the first triangle. So I'm saying A here, A corresponds with D. So I would put in D here. Angle B corresponds with E. So I would put E here. So the letters have to be in the exact same spot in each of the names. All right, so you know scale factor, which was a previous lesson. You know corresponding angles are congruent in similar figures, and you know that corresponding sides create this ratio, which is your scale factor. Alrighty. Now, what this lesson is wanting you to learn is there are three specific ways that you can identify similar figures. And if you can use one of these three ways, you don't have to sit here and try to figure out all of the corresponding angles and all of the corresponding sides. So the first way is called AA similarity. And A stands for angle. So this is saying that if you can identify into triangles that two angles correspond, that means they're congruent, they're correspondingly congruent, then you can say that your two figures are in fact similar. And then therefore all of those corresponding angles are congruent and all of the corresponding sides are proportional. So here it is right here. And here's an example of two triangles. And this one has a double arc. So he corresponds with this guy. And both of them with the double arc means they're the same measure. And this guy right here has a single arc. So that means he is a same exact measure of this one right here. So I have identified two angles. That's AA in the two different triangles that correspondingly are congruent. Because that is evident there, I can say that these two are similar. Then that's what this assignment is getting you to understand. And literally, that's all you have to do is identify. Now, sometimes you have to work a little bit harder. Sometimes they're not marked. Sometimes they might have numbers to represent the angle measures. So, for example, over here in this picture, we have here it has numbers. Now these numbers are the same, so it's not difficult. This one has angle 72, this one has angle 72. Those are the same, so we know both of these angles are congruent. And this one has 35. So you know this angle here is the same as this angle. So boom, you got yourself angle similarity. And you can create those similarity statements and identify the corresponding sides. Now, if you come across an example where you don't have the markings and maybe the numbers look a little off, like let me just change some numbers around real quick. So say you have a scenario where you got this triangle here and you got this triangle here, and maybe let's get a different color. This angle here is 20. This angle here is 80, even though it doesn't look like it. This angle up here is let's see, this one would be that one would be, let's change this one because I want to make sure it's realistic. So give me a second. I'm going to change that to a 70. Alrighty, that one would be a 70. So that's 70 and that's 20. And let's say this one up here is 90. Up here, this one is 90, even though it doesn't look like it. And then maybe this guy down here is 20. All right, so at first glance, these two triangles don't look like they have the same angle measures as I showed you before, but you do need to remember that all triangles, when you add the three angles up, you're going to get 180. So no matter what this guy is right here that you don't know in this triangle, you do know if you add him with the other two, you'll get 180. So 70 and 20 is 90. 90 take away from 180, because like I said, all triangles will give you 180. If I subtract 90 from that, what's left to represent that angle right here is 90, because 180 minus 90 is in fact 90. So that shows you that this angle X here is 90. That one is 90. This one's 20. This one's 20. And once again, knowing that all angles have to add up to 180, you know this guy is 70. So at first glance, it didn't look like they had the same angles, but if you just add the angles up and find that missing angle by subtracting their sum from 180, you will find that they were in fact congruent. Now, if you come across any triangles that even after you tried to figure out any missing angles and they weren't the same angles, and you had no evidence that they did have the two angles congruent, then you would have to say that your two triangles are not similar. That would be your response, that you do not have similar triangles. All right, so what I'm going to do is I'm going to give you time to work on this, okay, this assignment. And I'm going to turn this off real quick here. Let's see here. I don't know how to turn this on.